Hello friends, good afternoon. Myself Dr. M.H. Annaya. In this video, we are going to work out a problem on the development of the lateral surface of a square pyramid which is being cut by two section planes. One of them is horizontal and the other is inclined at 30 degrees to the horizontal. And we are required to draw the development of the lateral surface of the lower part of this. So friends, I am going to show the horizontal section plane as 1, comma 1. 1 is the horizontal section plane and this is section plane 2, 2 is the second section plane. Both the section planes are perpendicular to VP and hence they are seen as lines in the front view. Both the section planes 1, 1 and 2, 2 meet at the midpoint of the axis. So we have to locate the midpoint at a height of 35 millimeter from the base and we have to show them. And the portion for which you are going to draw the development is this part. And remember friends, here this pyramid is resting on HP on its base with two of the base edges equally inclined to VP. That is at 45 degrees to the horizontal and 45 degrees to the horizontal. Two edges of the base are equally inclined or all the base edges are equally inclined to VP. Friends, you will mark this as ABCD, A, B, C and D, and the side of this is 30 mm. So anywhere we can just show this side has got a dimension of 35 millimeter. This 35 SQ to say. We need to draw the development of this part below the section plane 1 and 2. I will call this portion as 1 and 2. So this is the part for which we are going to draw the development. Friends, let's mark all these points in the front view. This is A dash, this is B and D, B dash, D dash and also O1 dash. Finally, this is C dash. This is O dash, the vertex, and O1 dash is the center of the base. So I have to mark O comma O1 here. O comma O1. So friends, we have drawn the front view and top view of the pyramid in the position specified in the problem, and we shown the section planes 1, 1 and 2, 2, now both intersecting at the midpoint of the axis. And now friends, let us see how to draw the development of the part P which is below the section plane. Friends, for all the problems on the pyramids or prisms or cubes or cones, you have to first of all draw the development of the lateral surface of the pyramid, say in this question, assuming it is not cut by any section plane. And for that, you know very well, we need to have the true length of all the slant edges. That is, the true lengths are O dash C dash and O dash A dash. Since OC is parallel to VP, this will give you the true length, even OE will give you the true length. So friends, taking this true length as the radius, I am going to just draw a vertical line. Say this is O and this is some point you will take later on. And taking this O as center, true length as radius, I am going to draw a sector, an arc like this. And on this I am going to mark 30, sorry this is 30 millimeter, not 35. 30, 30, I am going to step off distances of 30, 30, 30, say 30, this is 30 and another 30. So I am going to mark off this distance of 30 millimeter each. And I am going to join that last point to this O. And Let me show all these lines as OA, OB, OC, etc. This is OA, say second, this is third. And all these pyramids will have what is called straight edges. So I have to join all these by straight line, second straight line, third, similarly fourth. So I am going to join all these by straight line. Next arises the question, where do we start the development from? In this, if you observe friends, none of these slant edges OA to OD are totally removed by the section plane, and hence you can start the development from any one of these slant edges. Say I am starting from OA. So this is OA, OB, OC, OD, and again OA, because first and the last should have the same measurement. Now after this friends, let's see where all the section plane is cutting the solid. If you consider section plane 1 1, it is cutting the slant edge OA or O dash A dash at this point. OA is the true length, and we can simply transfer this distance from O to this point here. So O to A I am going to transfer. So on OA I just mark that. Again on OA I am going to mark the distance. Say this is OA. These two distances are same. Next friends, it is cutting OB and OD. But OB and OD, as you see, they are not true length. Hence, this point has to be transferred to the true length line. Take the same measurement on OB and OD. So this is on OB, you have a point, and OD, you have a point at the same distance. So all these are at the same distance. Distance of OA, then OB, OD are the same. Let us see. So these are all the 3 points where the horizontal section plane is cutting the solid. Next friends, we have the second section plane which has got a common point here. So it is cutting again OB and OD. OB and OD are these 2 points. And then the last slant edge O dash C dash is cut here. And this is the true length. Hence you can take this measurement and mark on OC. So I am going to mark on OC at that distance. See friends, we have got all the points where both the horizontal and inclined section plane are cutting the solid. So friends, as usual, for all the pyramids and prisms, including cubes, the points so obtained are to be joined by straight line. So before that, let me mark this as 1, 2, 3, 4. This is 1, this is point 2, point 3, point 4, and point 1, because OA should have the same points. So let me join all these by straight line. So 1 to 2. So this is going to be a straight line. Then 2 to 3, second straight line. 3 to 4, 4 to 1. So this is how you get friends. Let us name them as 1, 2, 3, 4. Already we have done. And friends, you can see here the portion below this horizontal section plane, say, is all retained. So I am going to show the base edges go A to D, D to this, C to B, all these by straight lines, and this by straight line. So I join them, and this portion, suppose this is 1, and OB, OD are 2 and 4. This point is 2, comma 4. 1, 2, 4. So here this has to be shown by a visible line and a dark line, this by a dark line, again this by a dark line, till here, a visible line here, another visible line here. Friends, I have shown all these lines, And here the portion above this, portion above 1, 2, 3, 4 is removed, and this will represent the development of P, that is the development of the lateral surface of the lower part of the pyramid when it is cut by two section planes 1 1 and 2 2, both being perpendicular to VP. And friends, here you have to remove all this thin line, that is to say from 1 to this you can remove, or you can retain it as a thin line, because all the base edges of the solid are straight. The arc has to be removed. So I have removed that. And similarly here you can remove this line also, or you can show it by very thin line if you want to show the construction line. And this figure 1, 2, 3, 4, 1, A, B, C, B, A, and this one will give the complete development of the lateral surface of the pyramid. Friends, you have to observe one important note here. See here, this section plane 1 1 till here is parallel to the base of that. That is, this is 1 to 2, and these lines should be parallel to this. AB, similarly 1 to 4 is parallel to AD, and this is what the observation you make. Friends, I am very confident that all of you have followed the instructions given to solve a problem on the development of a square pyramid. And if you are happy with the presentation, friends, please share this information with all your friends. Have a blessed day.